Today we're going to learn about scatter plots. You should be on page 6 in your notes packet. Example 1 gives you data that shows the ages of children in Mackenzie's neighborhood and their weekly allowances. We are going to use this data to create a scatter plot. The first thing you notice is that you see age here. Well, just like with any table, your first column will represent your X values and your second will represent your Y values. So age is going to go down here on our X axis, and we know that allowance is going to go over here on our Y axis. Now we can see that our first set of data is that at age 11, one child in Mackenzie's neighborhood earns $0. So we're going to go to age 11 on the x-axis, and then because that child does not earn any money, we will just put a point here. Our next point is that a child in her neighborhood that is 12 years old earns a $5 allowance. So we will go to 12 years old for age, and then up to $5 for the allowance, and we will put a point. Next, we have a child age 14 who earns $20. So we'll go right to 14 and then up to $20. And this would actually go off of your graph, probably somewhere around here. Then we have a child who is age 15 and earns $10. So aged 15 who earns $10. Then we have a child age 15 who earns $25. So this is going to go even further up than that other point. Then we have a child aged 13 who earns $15. We have a child who is 11 years old who earns $5. A child who is 15 years old who earns $30. So again, this one's going to go even further up. A child 14 years old who earns $20. So that would be the same as this one because this point, and this point are exactly the same. Then a child 12 years old who earns $8. Now, from your scatter plot, you can see you could not connect these with one straight line. A scatter plot does not give us a linear equation typically. What it does is it shows us what we call the association of the data. We can look at this and we can see that typically, as we get further to the right on our scatter plot, our points tend to go higher up. Well, we can draw a conclusion there where it seems as if as a child's age increases, their allowance also tends to increase. Now, of course, we always have what we call outliers for this. So we always have points that don't necessarily fit into a perfect pattern. So we're going to learn about that later this week when we talk about outliers and finding what we call a line of best fit. Now let's look at our graph and let's answer these two questions. A says, what does the point 13, 15 represent? Well, remember that if we see 13 is our X value and 15 would be our Y value. Well, 13 on the X-axis means that someone is 13 years old, and 15 on the Y-axis means that they earned a $15 allowance. So the point 13, 15 means a child who is 13 years old earns a weekly allowance of $15. So that point represents one specific child. B says, does there seem to be a relationship between a child's age and their weekly allowance? And explain. Well, we already said that it actually does seem that a child's allowance will increase as their age increases. Example 2 shows another scatter plot. This one shows the heights of dogs and weights. I want you to take just a minute right now to analyze that data. When you look at this data, you can see that typically as the weights are getting, or as the heights are getting larger, so as we go to the right, the points also seem to move up. So the weight also seems to get larger. So we can see that there seems to be an association or a correlation between a dog's height and their weight. So it seems to be that as a dog's height increases, their weight will also increase. What does the point 1215 represent? Well, in this case, you have to pay attention because a dog's height represents the X values and their weight represents the Y values. So in this case, 12 represents the height of the dog in inches and 15 represents the weight of the dog in pounds. That means that that particular point represents one dog whose height is 12 inches and whose weight is 15 pounds. B says, what is the height of the tallest dog? Now you have to be very careful here. This is asking for the height of the tallest dog. Well, height is going to be right here on our x-axis. So if I'm looking for the tallest dog, I'm looking for the point that is furthest to the right in this case. Well, I see that there are actually 2 points that look to be furthest to the right, and they're about the same on the x-axis. And if I look at them down here on the x-axis, they are at 27. That would tell me that the tallest dog is 27 inches tall. Now, what is the weight of the heaviest dog? Well, in this case, the heaviest dog, remember weight is over here on the y-axis. So if I'm looking for the heaviest dog, I'm looking for the point that is furthest up on my graph. Well, that is going to be this point because this point is the highest point. Now, since I'm looking for weight here and not height, then I need to come over here and see about what weight that would be. Now, it looks like it's getting close to 112, and it may not be exactly 112. So it's a little bit below that. So we can say maybe approximately 110 pounds. Now, I want you to answer the last 2 questions. D says, what is the weight of the shortest dog? So you had to be careful here because it actually asked for the weight of that shortest dog. So the first thing we've got to do is find our shortest dog. Well, that's looking at height. So when I look at height over here, the shortest height is going to be the height that's furthest to the left. So that's this point. Now, this is not asking me what is that dog's height. This is asking what is that dog's weight. So I would come over here and I would say, well, it looks like it's about right here on my y-axis. So it's somewhere between 0 and 16, but it seems to be closer to 0. So I might say it's approximately 5 pounds, and you might have a different answer because we can't see exactly where this is. So anywhere that's close to that, but it definitely needs to be below 8. Because it's not halfway up. So approximately 5 pounds is the weight of the shortest dog. What is the height of the heaviest dog? Well, we already found our heaviest dog was this dog right here. We knew that because heaviest is over here on my weight, so it would be the point that is highest up. Well, this point is our highest point. Now, this doesn't ask for its weight, it asks for its height. Well, its height is going to be down here. So when I look at its height, I see that its height is right here at 27. So the heaviest dog has a height of 27 inches.